So we are going to spend a few moments graphing a logarithmic function. So the function we have now is f of x equals log base 3 of x minus 4 plus 1. And so very similar to graphing our exponential function, we're going to break this down into our parent function and then transform the graph later on using what we know about transformations. But there's one extra step that helps us graph logarithmic functions more easily. So same as before, write the parent. So our parent function gets rid of all the extra numbers except our logarithm and the variable. So our parent is y equals log base 3 of x. The extra step that we're going to take to graph a logarithmic function is to transform this into exponential form. So I'm going to circle our base, spiral around, and so in exponential form, our function is 3 to the power of y equals x. The reason why this is helpful is because when I make my table, I like being able to plug in numbers for exponents. Exponents are really easy to work with. Logarithms, not so much. So I'm going to plug in the same three numbers as we used before for the exponent. In this case, our exponent is y. So I'll have negative 1, 0, and 1, but they're in the y column this time, not the x column. And then I plug in all my numbers. So 3 to the power of negative 1 is 1/3. 3 to the power of 0 is 1. 3 to the power of 1 is 3. Now, that's a lot easier to do than trying to think, what are nice values that I can plug into logarithms? Because unless we're working with a calculator, it's not going to work out well. So now what I can do on my graph, I'm going to label my y-axis, so negative 1, positive 1, and then I only need to go out to 3 on my x-axis. So 1, 2, 3. And so now I can plot my points. 1/3 comes down to negative 1. Then 1 stays at 0. And 3 goes up to 1. That should be a little bit straighter. So now I can draw in my curve. And this looks very similar to an exponential curve, except rather than increasing upwards, it's increasing and getting flatter. Now, if we remember the relationship between exponents and logs, they're inverses. And when we make an inverse, we switch the x and the y's. So everything that was horizontal before is going to turn vertical, which means our logarithmic function has a vertical asymptote at x equals 0. But as before, when we transform our function, things are going to move. And so starting by moving that asymptote first is going to help us more easily graph our transformed function. So let me draw a new graph. So here, this should be good. The inside at -4 says we are going to shift to the right 4 units. So I need to number out to 7 because our highest point before was at x equals 3. So now I need to go 4 more to x equals 7. So 1, 2, 3, 4, 5, 6, and 7. This plus 1 says we're going to move the whole graph up 1 unit. So if we started at -1 as our first point, we're going to start at 0 now, which means I have to go up to 1 and then up to 2. So at 0, right? I'm getting ahead of myself. What did I say the first thing is we want to graph? Our vertical asymptote. And if we're shifting everything 4 units to the right, our vertical asymptote is going to come through x equals 4. And now that I have the vertical asymptote, I can draw the first point. -1 comes up to 0, and that's just slightly past at 1/3. And then I go up 1 and over 1. So up 1 to 1, and then over to 1. So here we go. And then at 2, I'm going to go 3 past the asymptote. So at 2, 1, 2, 3. Hopefully everything looks at the right level. Okay. And then I can draw in, starting really close to the asymptote and curving through those points. And so this is now our completed graph of the transformed logarithm. It's very similar, again, to the process of graphing exponential functions. With a key difference, we're going to change our logarithm into exponential form to make creating a table of values easier to work with. So this has been graphing a logarithmic equation.